Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 14 of the November daily LeetCode challenge. So again, a congratulations to all of you who have made it till here, because now you have completed exactly 2 weeks into the November daily LeetCode challenge. So congratulations if you have been here till now. It doesn't matter how many you solve. It doesn't matter, because if you have been here, then at least you're learning something new compared to others who are not doing that, right? So that is something that will, keep you apart from others, right? So coming to today's question, it's somewhat similar to what we had yesterday. Okay, yesterday also we had a tricky question. Here again, it's a very very tricky question. Okay, here basically they are trying to teach you only one particular thing, because see, again, like yesterday, if you see the time complexity, the way they've given it, okay, if you try to solve in other approaches, this will not work. Okay, these are some of the very tricky questions in lead code. They doesn't require the knowledge of the algorithm as such. You just need to follow your what based on the observation, based on the complexity, you'll have to take approach and you have to follow that. Okay, so these are more situation specific. Okay, you cannot be generalizing them. Okay, these kind of things you cannot be expecting in a face-to-face interview, because there are not many approaches to solve these kind of questions. So I'm telling this in the starting itself. Okay, let's see the question that we have today. I'm telling the starting itself, it's going to be tricky. Okay, so there are very less approaches for this. See, if you try the brute force, you can get the answer, but it won't be segmented. Okay, that is, it will not be accepted for all the test cases that we have. Okay, in lead code. So that is the only disadvantage of this kind of questions. Okay, but according to me, this kind of questions should not be asked in a face-to-face interview, because there are very less approach possible in this kind of questions. Okay, let's see what it is. 2064, minimized maximum of products distributed to an store. Okay, so what is that? So basically, if you see here, you are given n and you are given a quantity. Okay, so out of 10 you have written integer. What it is, we'll see now. Okay, so basically, okay, before starting, let me tell you something. So what is n is basically representing how many stores you have. Okay, how many stores you have. What are these things this represents? Okay, each value here represents that a particular type of product. Okay, and it also represents the number of that particular product. Okay, that is the type 1, that is product of type 1 has 11 such samples. Okay, similarly, the product of type 2 has 6 such samples. Okay, and this represents the number of stores. So this is all about this question. Let's see what they are asking here. Okay, so you are given an integer n, indicating there are n special retail stores. Okay, that's what I mentioned. There are m product types. Okay, varying amounts, which are given as a zero index integer array of quantities. Okay, where quantity of I represents the number of product for the ith type. Okay, so if you see here, these are the various product types and the quantity present for each product type. Okay, if you see here, the 11 basically represents the number of quantity, that is 11 products are present for the type 1, as simple as that. Okay, you need to distribute all products to the retail stores following these rules. Okay, so basically what you have to do, you have to distribute these two products, okay, these two type of products among 7 stores. Okay, that is the basic idea. Remember, there are two type of products, but how many we have? We have total 17 products. Okay, and these 17 belong to two types. Okay, for the first type there are 11, for the second type there are 6. Okay, so you have to distribute them among 6 stores. Okay, that is the basic idea. Now let's see what are the rules to be followed while distributing. Okay, so a store can only be given at most one product type. That is, for example, I have 6 stores. Okay, okay, let me just do this. So what we have to do is, see, just think of it. Let us say there are two types of products, so A and B. Okay, we have A and we have B. Okay, let me zoom in. So what they're trying to tell here is that, so you have 6 stores. Okay, so what I can do is, I can only, for example, I'm giving A to 3 stores, and then I'm giving B to 3 stores. Okay, that's what it is. Okay, the idea here is, since you have given A to this particular store, see, total stores are how many are there? There are 6 stores. Okay, in the question also we have 6 stores, right? Fine, but remember one thing. Once you have given A to a store, you cannot give the type B to the store. Okay, that is the idea here. Is, if you see, a store can only be given at most one product type. Okay, that can be given in any amount. For example, here I've just mentioned the type. I'm not mentioning the actual amount that I'm going to give here. Okay, so idea here is, once a type of the product is given, you cannot give them any other product. Okay, any other product type, as simple as that. Okay, fine. What is the second one? After distribution, each store will have, okay, each store will have been given some number of products. Okay, possibly 0, you might not have given anything to it. Okay, let x represent the maximum number of products given to any store. Okay, you want x to be as small as possible. Okay, you want to minimize the maximum amount of products that, okay, we'll see this. Okay, so what they're trying to say, they are asking us to find the minimum possible x. Okay, so what I will do is, I will create 5 stores here. Okay, so let us say store 1, just a second, store 1, store 2, store 3, store 4, store 5, and store 6. Okay, the other 6 stores I have. Okay, So what are the quantities now? 11 and 6. Okay. Let us say currently I am writing 11 and 6 here. Okay. 11 and 6. So that means what? Other stores have 0. If you see here, other stores are having 0 of it. Okay. Initially. So if you try to find the answer at the way it is given, okay, so you will get that the answer is going to 11. What is 11 here? If you see, basically what I have to written is, see, among all the stores, you have to tell me which store has the highest number of products. Okay. So see, you can distribute it. For example, this 11, you can maybe distribute something to here also. Okay, something to here, something to here. You can do that. After that, what you have to return the answer? You have to return me the maximum number of products present in any one of the stores. Okay. For example, see, let us see like what happened next. Okay. What is the step one? See here, there are 11 present. Okay. The highest is 11. So what I will do, I will try to distribute some part of it. Okay. I will try to distribute some part of it to the other store also. Okay. To the other store. So what I will do, let us say divide, because see, this is contributing to the answer currently. Okay. 6 is not contributing to my answer. Why? Because see, highest is 11, right? This we have to reduce the highest. Okay. That's what the answer is. Okay. We want to minimize the maximum number of products that are given to any store. Okay, remember that. Only read this thing. Okay, don't have to read the whole thing. This is the question basically. Minimize the maximum number of products that are given to any store. Okay, so since only 11 is contributing to the answer currently, I want to minimize the 11. So what I will do, I will be dividing it. So what will after doing, what it will look like? It will look like 5.5. Okay, just for now sake of dividing, let me do it 5.5. Okay. Okay. 5 and 6. Okay, so 5, 6, and here another 5. Okay, so basically it will be 5.5 and 6. Okay, 5.5 and 6, but yeah, you can also write it like, because 5.5 is not possible, so let me write 5 one place and 6 one place, right? This is what it is. 5 and this, okay, this will remain 0 and this will remain 0 and this will remain 0. Okay, fine, we are done now. So okay, so previously we had the answer is 11, because what is 11? 11 is basically the, you have to see minimize, but what is the maximum current, maximum number of products that are given to any store? What is that? It is 11. So this step, the answer was 11. Okay, so what I did now, I did distributed this 11 among two stores. Okay, one itself and the other one is this. Okay, so what is the answer now? The answer now is going to be 6. Okay, so if you find the answer this particular step, the answer is going to be 6. Still there is option to simplify it further. So what we can do now, this particular 6, what I will do is, I will see, this is the highest, right? This current going to my answer, I will again divide it by 2. Okay, so 3 and 3. So what will happen, this will remain 5, this will remain 6. Okay, just a second. Yeah, this will remain 6, this will become 3, and this will become 3. Okay, so what happened basically, I distributed the one which is connected to the answer into 2. Okay, I divided them as simple as that. See, I still have 2 which are empty, so I can still assign something here also. So what I will do next, this is the highest now. Okay, this is contributed to answer. So again, I will divide this. What will happen after that division? What it will look like? It will have 3. It will have 3. Okay, yeah, it will have 3, and now this also will have 3. Okay, this will have 0 again. Okay, so what I did, this 3 I divided. Okay, so 3 will remain in this, and another 3 will go to this. Okay, that is fine. Next, what I can do, see which is contributing to the answer, and this 5 is contributing to the answer now. Okay, because this is the highest now, I have to do something to reduce this as well. Okay, so only one is vacant now. So what I will do, I will again do a division there. So see, 5 you cannot divide by 2 directly. Okay, that is, it will give 2.5, which is not possible here. So what I have to do, I have to keep 2 and 3, and so one of them will have 2, the other one will have 3. Okay, so let me keep 2 here. So it doesn't matter which one keeps 2, which one keeps 3. Okay, that is not going to change my answer in this question. Okay, so yeah, if you see here, and finally I will keep the second 3 here. Okay, if you see, yeah, so this 5 basically became divided into a 2 and a 3. Okay, so if you try to find the answer, now you will get that 3 is the answer, and that is what they are trying to return. Okay, that is what we have to do. So I have shown you the approach. So basically we are trying the greedy approach. So what we are doing is, the one which is going to contribute the answer, I am going to keep dividing it as much as possible. Okay, I am going to keep divided as much as possible. Okay, this is going to be my algorithm. Okay, so if you see here, what I'm going doing, see, the idea here is, first of all, divide, that is, give all these cookies, that is all these quantities of whatever these are, so all type of, that is, take one type of the product and give it to any one store. Okay, in this case it was S1. Okay, similarly, take the second type of product and give it to S2. Okay, so like that. After that, what we'll do is, the store which are unassigned, we will start assigning them some of them. Okay, we will divide the one which is contributing to the answer, and assign half of it to one of the unassigned ones. Okay, that is what we are going to do. So if you see the constraints here, M is always going to be less than N. That is, the idea here is, the type of products is always going to be less than the number of stores we have. Okay, that is what they're trying to say. Okay, that is the basic idea. M is always going to be less than N. Okay, or equal to N. So can you quickly tell me, if N and M are same, what will be the answer? See, the idea in that case, what it becomes is that then distribution is not possible at all. See, the idea here is, if N and M becomes the same. Okay, for example, here also N is 3, here N is 3, and here this is already 3, m is also 3. Okay, so what will happen? So division is not possible, so whatever it is there, we have to keep them assigned as it is only. So in that case, what will the answer will be the max among this particular array. Okay, as simple as that. So that is why we have to take advantage of a smaller RAM, and we are doing that. Okay, so first we will be assigning them to the stores. Okay, so directly assign pool, like for example, I have a product of type A, so all the products of type A I'm going to assign to a one store, and as it is. Okay, and then I'm going to do this step. Okay, as simple as that. So let us see what we are doing in this solution. As I mentioned, this is going to be tricky. I'm agreeing with you that yeah, this is tricky. Definitely this is tricky. But yeah, like lead course want us to learn this, so we have to learn this, right? As simple as that. So what I'm doing, I'm taking M. First of all, M is going to the length of the quantities. Okay, I am taking a min heap. I am taking a min heap. See, because I need to know. Okay, at each iteration, I need to know which is having the highest. For if you see here, basically what is happening. See here, 11 was the highest, right? Here 6 is the highest, right? Here 5 again 6 is the highest. Here 5 is the highest. How I get to know that? I'm getting to know that through a heap. Okay, that is the basic idea. And remember one thing: when we are using this particular library, that is heap library, by default they have implemented a min heap. Okay, so in this case, we don't want a min heap; we want a max heap. So in order to convert the min heap into a max heap, I will be using a negative value. Okay? I will be just appending a negative value so that the min heap behaves like a max heap. Okay, simple as that. So what I'm doing, see, this is going to be one element in a heap. What is this element signifying? This represents three values. Okay, each element here has a three values. What are they? See, the second value. Let's start with the second value first. What is the second value? Second value tells me, okay, the total number of, that is total quantity. Okay, so see what I'm going through quantities, right? What is a quantity? Basically, quantity tells me, for example, this is the type A. Okay, so for the type A there are 15 products. Okay, so this tells me what is the quantity for that particular type of product. Okay, so total quantity here, that is going to be I. Okay, next, so what I'm going to do in starting, so I'm going to assign this whole quantity of a particular type to a given store. Okay, to a given store. So initially the number of stores is going to be one. Okay, initially for all of them, for all type of products, the store is going to be one. Okay, so for each type of product, the store is going to be one initially. Okay, and then the average quantity per store, that is, so among, if we divide all the products among the stores, what will happen? See, the idea here is I'm going to divide all the 15 of type A to a single store. So obviously, all the quantities will be there in a single store itself. So this average you will get to know when you follow the algorithm. But for now, it will be minus I. Okay, why minus I? I already explained, because we are going to implement a max heap. Remember that. So we don't. But this algorithm, this particular library basically implements a min heap. For that reason, I'm keeping it as minus I. Right. Then I'm starting the heap. Okay, I've already formed the array. Then I'm doing the in place sorting to using the heapify library. Okay, it will take OFM time. Remember that. Next, what I'm doing, I'm just printing it for your understanding, and then I'm putting n minus n. What is n minus n? See, this tells me how many stores are unassigned. Okay, so these many stores we have to assign. Okay, in the next. Okay, so I'm going to run an iteration for n minus m. Okay, so that in each of the empty stores I getting assigned some value. Okay, so what I'm doing, I'm popping out the I'm popping out the among, see, if among these elements, the one having the highest average, I'm going to pop that out. Okay. Remember, in heap, what happens is the sorting happens based on the first value. Okay. So whichever element has the highest first value, that will be sorted. Okay. Similar to that, and then it will be popped out having the minimum value. The one having the minimum value will popped out. So what I'm doing, I'm popping out these things. Okay. The first value is being stored in the underscore. Then the other second value is total quantity, and the third value is total stores. Okay. This is getting popped out now. Okay. It will take log m time. Next, what I'm doing, I'm just going to add the total stores plus one. So what I'm doing is here, I'm going to take this 11 out, and now I'm going to distribute it among two. Okay, that's what I'm doing here. If you see, so I'm distributing. So the distributing basically means I'm going to add. That is, I'm going to divide the particular quantity of that in one more store. So I'm just doing total stores equal to total store equal to plus one. Okay, so I'm just incrementing this by one, as similar as that. Then I'm again finding the average. So if you see the total quantity divided by total stores, I'm getting the average. I have to while framing the element, this is while again pushing the next element, I have to ensure that I'm assigning a minus value to it. Okay, I'm now inserting another string. Okay, just a second. Yeah, so since I popped out the value, after that I need to pop in another value, as simple as that. Okay, why this needs to be popped in? Because after this, okay, after the division process, I need to pop in so that it presents what is the real value of it now, what is the real average of it now. Okay, after the after adding another store to it. Okay, so I'm just popping inside, pushing inside this. Okay, so this element will be now reintroduced to the heap, and it will be done heap push away. Okay, then I'm again printing it. So let us quickly show you the output, then you will get to understand this. Okay, in just a second it will throw error because this part I have to comment. So see, if you understood this part, the whole question is simple now. So we will go with a good example, yeah, like this. Okay, so what is happening here? N is equal to 6 and M equal to 4. Okay, so this is how it will look like initially. Okay, so what are these values? See, this is going to be the average in a negative way. So just while understanding it, just ignore the negative sign. Okay, so this is the average for this is the average for this, and see, all the first values are average. Okay, all the first values are average. So what are they? See, this represents the total number of quantity that I have. Okay, and this represents this quantity is divided among how many stores. Okay, initially everything is one. Okay, so this is the quantity. So this is a type of good which has four quantity. This is a type of product which has four quantity. This is a type of product which has three quantity. Okay, like that. So initially these are divided among one stores. Okay, I'm just keeping them in a one single store. Okay, then I'm checking which is having the highest average. Okay, here six is contributing to the answer. Okay, so see, the next thing is what is n minus m. Okay, so this tells me how many stores are empty. If you see here, there are six stores. Okay, initially what I will do, I will assign all the quantities to a single store. Okay, so four stores are now filled, other two are empty. So we can run this loop for two times. Okay, so what we'll do next, take the one which is having the highest. Okay, take the one which is having the highest. Okay, quantity will remain the same. Okay, but the store I'm going to increment by one. Okay, so this will become 6 comma 2. Okay, this will become 6 comma 2. Now find the average, so it will become 3. Okay, 6 divided by 2 is 3. So just include a negative sign again, so this becomes like this. Okay, now it is sorted after that. Okay, so after sorting it look like this. Okay, next what I have to do, find the one which is having the highest average. So if you see here again, this is going to have the highest average now. Okay, so pop that out, increment the store by 1. Okay, so it becomes like this. Okay, it looks like this now, and update the average. So after that, see, since two were empty, I have already done the loop for two times. Okay, so this area what I see now is going to the final. Okay, so what are the thing now? See, 3, 3, 2 and 2. Okay, so this is how it is going to look like. So the answer is among them highest. So the highest first value among this is going to be 3 here. Okay, if you see the highest. Okay, so you have to just give out 3. But like, you don't have to compare everything to get the highest value. Remember, this is a already sorted one, right? So obviously the first element is only going to have the highest value, right? So you have to just take this and you have to return. And remember one more thing, if the first value has some, let us say 2.5, so 2.5 we cannot return, because see, 2.5 doesn't signify anything. Okay, we cannot have it in decimals, right? So we have to basically take the seal of that. What is seal? Seal basically means that, for example, 2.5, what you will do is, see, you have 5, right? You are going to divide among 2, so one of the stores will have 2 and the second stores will have 3. Okay, so that is why you have to take the seal of the division. Okay, seal of 5 by 2, which is 3. Okay, so that is the basic answer. That's why I'm returning 3 here. So let us see the code now. So till there I explained. I'm going to start the explanation of this loop now. Okay, so again I'm doing the same thing. First of all, I'm popping the value, I'm storing it here. I did a plus one. I found the new average. Okay. Then I again appended that. And then yeah, I am blending this for you. Once I come out of this loop, that means once all the stores now have a value allotted, that is have a certain quantity of a product allotted. What I will do now, I will take again the first value. I will pop the first value, since the pop value is having the highest average. Remember that, so that is going to contribute for the answer. And I only need the average here. I will be returning the average. So remember, initially the average is negative. I will make it positive, and then I will return the seal of that. Okay. So let me quickly run this. So yeah, I already shown you the running of that, but yeah, this is going to the answer. Okay. So in this problem, what we learned basically, see, the idea here is we are not applying any algorithm message. Okay, you can call this as a greedy approach, but we are not applying any algorithm message. Okay, this is just based on observations. So maybe if this comes in a face-to-face interview, the lead code, the interviewer basically will expect you to trace some of the examples. Okay, and find out what will the maximum approach. See, the answer is given, but you have to tell them how it is coming. So maybe that can be done, and yeah, then they will push you to this kind of approach. Okay, they will say like this. Okay, they'll give some hint, then they'll be pushing you to get to this kind of approach. That is what can happen to a max that I can think of. Okay, because see here, there is not much to explore. Okay, so there is not much for an interview to check in a candidate. So I don't suggest this kind of problems if you're preparing for interview, because these are not the right kind of question to test the knowledge of coding for a student. Okay, so but yeah, since this came in the daily Leetcode challenge, so I'm just teaching you the way in which Leetcode expects you to solve this kind of question. That is fine. But yeah, only thing you can learn here is how to use the heap. Okay, we have used the heap here. Basically, you can also implement the priority queue using this particular library. Okay, heap queue library. So just learn how it works. Okay, we learned three methods in this. So the heap p5 method, that is any array, if you pass this, it will basically sort it out. Okay, and make it as a min heap. Okay, that is the first thing. Second thing is the heap pop method, that is it will just remove the first element, it will give it to you. Okay, you can do this manually also without this approach, but yeah, anyway, that is fine. But remember one thing, if you do it manually, okay, can you quickly tell me what is the difference between this and the manual removal of the first element? Okay, see, anyway, it is sorted, right? After this, it is already sorted. I can simply remove it, right? I can simply remove it. But why I need to use this library to remember? Once you remove the first element, that is, you have removed the say this mini, right? You have removed the smallest element. But remember, something should fill the place of the smallest element now, right? So basically, you have to imagine as a tree, right? It's basically a tree structure only. So basically, what will happen is some modification will be done in place, that is it will definitely take a log m time. Okay, I cannot display, I don't have a pen and paper here to draw it and show you how it works. But yeah, you have to imagine it is a tree, and what will happen is the layer will wait, one value will be taken to the root. That is how it will be flowing down. Okay, and that is how the structure will be maintained, heap structure will be maintained. Okay, so that's why it takes log m time. Remember, if you take element out and claim that okay, I can take it in O of one time, remember, you are destroying the heap structure. So to re-maintain the heap structure, basically you should you basically should use this library to pop a value out. Remember that. Okay, second thing is I'm doing heap push. Again, remember, the best part about heap is that the complexity here and here, okay, you see both are same. So what will happen in algorithms is that this will be O of one, but it's still very very high. That is, after inserting new element, you have to sort it again. So it will take full time. Okay, n log n time will be taken here. Okay, here it is just log m time. So that is the advantage of the heap here. Okay, so yeah, so what I going through these are the time complexities. So if you see here, this particular thing will take O of m time. Okay, this whole for loop, we'll just try to understand what is happening whole for loop. See, this for loop will run for n minus one time, right? Fine. And here we are doing two calls. Okay, two function calls, which each of them is going to take log n time. Okay, so if you take the overall complexity of this whole for loop, it is going to be O of n minus m into m. Okay, so this is n minus m and this is log m. Okay, fine. Next, if other than that, we have these calls. Okay, O of m and O of m. Okay, so basically the overall time complexity is going to be O of m plus this value. Okay, plus this value. And if we talk about the space complexity, so this is the only thing which is consuming space in our solution, so it is going to be O of m again in the space. Okay, so Stefan, that was all for today. I understand this question doesn't have much to teach you, but yeah, I'm waiting for a question in which I can show you multiple approaches. These kind of questions are not having that much to explain. Yesterday's problem was also like this only. Okay, but definitely good problems are on the way. We will definitely be solving them, and I will definitely have much to show you out in that. Okay, so Stefan, that was all for today. If you like my efforts, please do subscribe to my channel. It really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.